Hello, everyone. OpenStack is a complex service with a variety of use cases and configurations. So over the years, different deployment methods were developed for operators and developers alike. My name is Maciej Kucia, and I'm here with my colleague Maciek.
Hello, my name is Maciej Slczek. So you are listening to two Macieks. I think it would be funny if we had a presentation about high availability. Anyway, we have arrived here from Samsung Research Poland, and this presentation is for those who would like to choose the appropriate OpenStack deployment tool that the best fits their application.
Okay. Today we are going to start with some overview, what deployment is about, what things we should consider. We are going to talk about some basics projects, and then we are going to talk about more complicated projects. We are going to mention commercial projects, why it should be considered to use those, and finish with some summary. Okay. Well, first of all, we have our use case. So use case might be proof of concept cloud. In such case, we probably want to learn how OpenStack works. The other use case is obviously a deployment which is used in production. That's another use case. Lifecycle management. Lifecycle management, it's very strongly connected to deployment because often the tools used to deploy OpenStack will be used to manage it after the deployment. Actually, deployment is just one single operation that will be followed with this long maintenance period. We will have to upgrade, we will have to reconfigure our cloud. We have different OpenStack projects. So maybe not every single deployment project will handle all of those projects. That should be considered as well. We have different operating systems. So the two most popular families of the operating systems, one is based on RPMs and the other is based on aptitude package managers. Bare metal provisioning. Well, in order to have installed our services, we need to have those nodes. So we need to consider this as a part of deployment of the cloud as well. What tools do we have? Well, we have Ironic. Ironic is part of the OpenStack. It can provision bare metals with pre-built images. There is Bifrost project, and the Bifrost project conveniently connects Ironic with Ansible playbooks. There are many other methods. There is, for example, Fedora Kickstart, which is used for provisioning operating system, and there are some novel approaches. Nowadays, we can have those unikernels which are optimized for container workloads. Those minimal operating systems can be provisioned through PXE, and they reside in memory. Finally, containers. So our cloud, our control plane, can be containerized. And if it can be containerized, it also can be managed by tools like Kubernetes. Okay, talking about containers. It's important to understand the difference between what is a containerized OpenStack and OpenStack with containers. So containerized OpenStack means that our control plane, our OpenStack services themselves are inside containers. On the other hand, the OpenStack with containers means that our cloud can provide containers as a service. So we can run containerized applications on our cloud. And for example, in OpenStack, there is a Zoom project that can do that. Finally, with the containerized control plane, we can orchestrate this control plane with Kubernetes. Kubernetes is a very popular topic nowadays, although, in my opinion, it does bring some extra complexity. So we have 3 areas here. There's one missing. So the question is, what is missing here? What kind of configuration? Does anyone knows? Okay, so what about running Kubernetes on top of OpenStack? There is such configuration as well. This presentation is about deploying OpenStack, so this is something off topic, although we might have Kubernetes pods provision of bare metals. So we are starting to touch the provisioning here as well, which is, as mentioned before, part of the deployment. Okay, OpenStack Foundation Technical Committee. If a project is under technical committee guidance, is a good indicator that there is a strong community behind it. Well, containers are already mentioned, and Kubernetes for orchestrating those. Vendor lock-in. Well, if we choose some specific tool, are we going to make some fixes? What's going to happen if we will be forced to use some specific technology stack? So this is something really important to consider. Community maintenance. Well, some projects are not maintained anymore by the community. So the question is my organization capable to perform some changes in maybe 1 year, 2 years, when we upgrade our OpenStack, and we will have to change our tool by ourselves. Bare metal provisioning was mentioned already. So if we have hundreds of nodes, we need some automation to manage that. Cool. The first project is documentation. So manual installation is a very, very nice way to learn how OpenStack works, how to create configuration, and how different parts of OpenStack communicate with each other. So the documentation is provided for different operating systems, SUSE, Red Hat, and Ubuntu. But there's a problem. If you want to use OpenStack in production, not having automation is simply not acceptable. If something goes wrong, we need to have a way to restore our cloud to the working state. So great way to learn, but not so great way to use in production. Devstack. Devstack target audience are developers. So if we provide a VM and we install Devstack inside it, we can bootstrap a cloud. This cloud, by default, is all-in-one, and scripts use code from master branches, from the Git repositories. What does it mean? Well, it's probably not so stable. We are taking, the code which is not tested so much. So even for some simple proof of concept clouds, I would look for some other solution here. Okay, Kolja is a project which I personally think that really shines among the others. We are dealing here actually with two separate projects. Kolja is used to build Docker images. Those Kolja Docker images are used in many different projects, not only Kolja Ansible. Kolja Ansible, on the other hand, is used to provision those images. This project is quite powerful. So it allows us to make some changes, reconfiguration, scaling. It allows for upgrades. So it's quite flexible. We can introduce our own custom configuration for the OpenStack services here. What it doesn't have is bare metal provisioning. So if we want to have a big cloud, we need another solution to create those nodes. Well, talking about every single project here would be very time-consuming, so here is a short summary. You can see that most projects are centered around some specific configuration management technologies. At that point, I would like to emphasize the difference between Kolja Ansible and OpenStack Ansible. So the Kolja Ansible project is dealing with Docker containers. On the other side is OpenStack Ansible, which is using Linux containers. And Linux containers are, for example, not compatible with Kubernetes. OpenStack Helm. OpenStack Helm provides Helm charts. Helm is kind of package manager for Kubernetes. So this project will be used a lot in projects which are simply deploying OpenStack on Kubernetes. We have other tools like Puppet Chief. So there are organizations out there which already invested a lot in those technologies, not necessarily Ansible. So that might be a reasonable solution for them, reasonable choice. Although Ansible had recently become kind of industry standard, is getting more and more popular, especially after the Red Hat acquisition. I'm mentioning here a tool called PackStack. So PackStack can be used with Puppet. PackStack is simply creating some basic configuration for Puppet modules. There's an RDO community behind it. This is a community who is preparing OpenStack to work with RPM-based systems. Well, we have OpenStack Charms here, and OpenStack Charms is a project which is based on canonical technology stack. So I would look here for a vendor locking warning. Some of the projects are not maintained anymore, so probably I would not look into those. Triple O. Triple O means OpenStack on OpenStack. Well, it means that in order to deploy OpenStack, we need to have another OpenStack instance. So the OpenStack instance that provides others, it's called the undercloud. And the other are obviously the overclouds. This project is currently transitioning into containers and Kubernetes management. But its disadvantage is that it's quite heavy and the learning curve is quite steep. So maybe, Maciek, can you tell us about some alternatives for that?
Sure, yeah, I've got some more. Let's proceed and start with KOB. So the name KOB stands for Kolja on Bifrost, which is pretty much self-explanatory, at least to those who know what Bifrost is. Quick reminder, Bifrost and Ironic serves the purpose of provisioning. So KOB complements Kolja and Kolja Ansible projects with capability of doing the bare metal provisioning and more. I will cover it later. So it allows to deploy containerized OpenStack from scratch without need for stitching external tools for provisioning. KOB versus container orchestrators. So KOB basically avoids using container orchestrators such as Kubernetes or Docker Swarm because like any extra software in the stack, it adds some overheads and a little complexity. So without them, there's like one less component to worry about. Let's discuss briefly architecture. KOB manages cloud from Ansible control host, which is where KOB and Kolja are installed. And there is also a concept of seed host, which can be actually often is the same host, but doesn't always have to be. And the seed host is where Bifrost is running. It serves the purpose of provisioning. And by default, also on the seed host, container images are built. One can install KOB on Ubuntu or CentOS from PyPy packages or from source. And generally, the PyPy packages are considered more stable. So how KOB extends the pure Kolja Ansible, what it offers extra. I've already told about bare metal provisioning, but there are more. One addition is physical networks device management. So this is optional step. One can skip it or replace with external tools. And if someone wishes to configure switch using KOB, it has to be added to Ansible inventory with configuration to Ansible host vars, and the Ansible will do the job, the networking modules of Ansible. And it is even possible to apply device-specific configuration because there are device-specific Ansible modules. So as you can see, KOB really loves Ansible. Also, it provides possibility to manage host configuration. And by that, I mean doing stuff like setting NTP, YAM repositories, LVM, executing sysctl operations, etc. And finally, it equips operator with a very handy command line interface. And this command line interface provides commands such as KOB over cloud inventory discover, or KOB over cloud provision, which requests and waits until hosts are provisioned with operating system and become available via SSH. Another example, KOB over cloud service deploy, which run services in containers. The CLI is quite extensive. Moving on to the next point, KOB cooperates with Ansible Vault to enable encrypting the configuration for safety reasons. I would like to mention about one feature that is going to be added, which is really nice. It is utilizing Monasca for log collection and monitoring. What else? So KOB community actively develops and upstream changes to related projects. It is not official OpenStack Foundation project yet, but it's in the process of becoming one, so I would not worry about it. And it comes on Apache 2 license. The next one is Airship, and Airship is example of OpenStack on Kubernetes. It integrates various open source tools, providing sort of all-in-one framework for deploying containerized systems. So it's not only for OpenStack, it is generally for deploying Helm-based charts components. And it can handle every step starting from discovery, provisioning, up to managing lifecycle of deployed system. The architecture of Airship briefly. OpenStack infrastructure services run in containers. These containers are orchestrated by Kubernetes, and it leverages OpenStack Helm. And there are also Helm charts for Airship own services. So these services also run in containers governed by Kubernetes, and this is what they mean when they say that Airship is self-hosted. And because of this, Airship components can be upgraded like any other Helm-based components. An important aspect of Airship is using declarative approach. And what it is about. So Airship configuration, like a site configuration, consists of collection of deployment, collection of manifests, YAML files. And this YAML files defines the desired state that should be achieved when some operation like deployment completes. So all these documents are sent to Airship, and Airship figures out whether it's initial deployment or reconfiguration, scaling, upgrade, whatever. And it consists of information like hard assets, like bare metal nodes, like network configuration, soft assets like software versions, image locations, configuration, and all this is shipped to Airship. And I would like to mention one thing. The configuration is not just one huge, awful file. It's rather organized structure, hierarchy of files for different layers and areas, like hardware profile, host profile, software, secrets, and so on. So when all this is sent to Airship, Airship validates it. And the validation is not only syntactical, but also actually the backend services are contacted to check if the desired configuration is applicable. If it's not, it's gonna fail early. So the configuration we apply is also version controlled. Another important aspect of Airship is that it uses single workflow for all operations. So there is no difference whether it's initial cloud creation, reconfiguration, scaling, upgrade. The same process with the same step is applied each time. And this makes the framework predictable. Airship can handle bare metal provisioning because it has internal component called DryDoc, which is a provisioning engine with pluggable architecture that can do things like BIOS updates, firmware updates, and for initial implementation, a canonical solution called MAS has been adopted, but Airship wants to support Ironic. And recently, Airship community actually tends towards using Kubernetes cluster API with MetalCube and indirectly Ironic. Thanks to Kubernetes, it can do rolling upgrades and rollbacks. And I would like to add that Airship has this modular architecture, so it's possible to take like a single piece, single component of it, which we are interested in, and adopt for our needs. And to give you example, for SK Telecom and Starling X projects are using Airship Armada, which is sort of extended Helm client for advanced usage. Very recently, Airship has released version 1.0, and this release is now generally available and is described like enterprise ready. That would be all about Airship. Let's move to Starling X. So Starling X is a software stack for deploying and managing clouds. And by the stack, I mean it includes components like Ceph, Open vSwitch, DPDK, SRIOV, and it's optimized for edge cloud applications. And by that, I mean it is developed with an eye on reducing network latency and paying much attention to aspects such as security and high availability. So the project was born a year ago as a cooperation of Wind River and Intel. Actually, the Wind River Titanium Cloud commercial product has been open sourced. It scales very well. It can deploy various configuration, various scale, starting from a single node, single server type, all in one, through double server, which is a highly available variant, up to multi-server, multi-region architecture. And Starling X facilitates managing such as distributed architecture. The part of power of Starling X comes from its internal services. And these services do the really good stuff. I will discuss some of them. Configuration management, for example, handles things like discovery, provisioning, scaling, configuring both infrastructure services and host, and it does it with a declarative approach. Another component is host management, and it handles lifecycle management of the host. It can do host failure detection and apply automatic recovery when it's needed. It also handles monitoring and alarming. Software management can automate installing updates, patches, and it can also do a rolling upgrade with live VM migration when a reboot is needed. Talking about releases of Starling X. So there is currently a release that has been published in October last year. The next release is scheduled, targeted for around August this year. And Starling X plans that the further releases will use the latest version of OpenStack. Currently, Starling X community works on containerization process of both OpenStack services and own services. It will leverage Kubernetes and OpenStack Helm and Airship Armada. Because the first release does not deploy containerized OpenStack, it uses underneath Puppet. So it is available on Apache 2 license. And that will be all I think about Starling X. So Maciej, I give you the mic back.
Thank you. Commercial offerings. So community work can be extended, and there are companies out there that take this community work and add additional value. So what would be that additional value? First of all, the OpenStack services themselves. For example, in telco world, we need to have a very high performance. So we can take a Nova and create some custom scheduler that puts our application, our telco application, onto some specific resources to get the maximum possible performance. For example, we can allocate our VM with the memory, the CPU, and PCI devices that are located on the same fast data bus. And that's the one thing. And the other thing is we can get some cool configuration management, lifecycle management tools. So what you can see here is a screenshot from Samsung OpenStack for telco and IT solution. It's a part of the installation. And what you can see here is that operator has an ability to match some FizzNets with some specific ports on hardware. Well, why this is valuable? When we are deploying OpenStack, we need to train our operators. And this is a costly process, and it takes time. So by bringing those tools that reduce complexity of the OpenStack, we can save time and money. Finally, important part of the commercial solution is obviously support. Here is a short summary, and this is obviously biased, so those are my recommendations. I put this manual installation based on documentation as a great way to learn OpenStack. We have Kolja Ansible, and Kolja Ansible has both simplicity and power for learning, for both learning and for making a production cloud as well. What Kolja Ansible does not provide, I mean this bare metal stuff, is in Kyobi project. Well, we have TripleO, a mature project from the community. It's a complete lifecycle manager. And we have Helm, which is used in Kubernetes-based clouds. Okay, so I would like to show a bit difference between Kolja Ansible and Kubernetes-based deployments. Because we said a few times that Kubernetes is quite a popular solution right now, nowadays, but there are some downsides. And if you take a look at Kolja Ansible, you will see that it provides containers with a host networking pass-through. It means that the containers themselves will talk with operating system networking stack. There will be no extra stuff from Docker. There will be no extra bridges, for example. This is not the case in Kubernetes approach. In Kubernetes, you will see a lot of extra bridges because Kubernetes needs to manage this networking. What it means in practice? Well, if we need to debug networking and we have dozens of network bridges, it will be harder to debug than when we have this simple host pass-through approach. That's just an example. Of course, we mentioned Airship and Starling X. Those are fairly new projects, really worth looking into. Finally, commercial solutions. We can get some extra value for money, mostly some individual approach and some extra features. Okay, cool. So we have summary here, but this slide doesn't really connect with what I said at the very beginning about all these considerations regarding projects which are supported by different methods, or if we have what different kind of lifecycle management supported. Well, we could probably make such slide, but with a lot of bugs, and that will be outdated pretty soon. So yesterday, there was a meeting here in Denver about providing a solution for that. So currently, if you go to OpenStack.org webpage, you will find there a marketplace which lists different OpenStack solutions. You will find a list of OpenStack projects. But in the future, there is an ongoing work from the community and OpenStack Foundation to include the deployment tools there as well. So once this is done, you will be able to see different methods, but with all this data assigned for them, hopefully up to date and without any mistakes. Okay, so unfortunately, the deployment is a very broad topic, and we didn't have enough time to talk about every single thing. So I'm pretty sure a lot of you will be looking for some answers, and we are sorry we didn't provide those. But what I hope you will bring from this presentation is the perspective that will allow you to ask some relevant questions when you will be starting your adventure with OpenStack. So thank you very much. I can see we have still a few minutes. There is a microphone in the center. If you have any questions, please ask. Anyone? Yes, sir? Hello.
Hello. My question is on a more fundamental level. Is more like a difference between not for a public cloud. I can understand OpenStack is definitely needed for a public cloud. But for your own data centers, does it make sense to, if your workload is mostly Kubernetes, to use Kubernetes as a platform as opposed to OpenStack as a platform? What benefits extra are you going to get out of that if you use
Okay.
I mean, OpenStack on top of Kubernetes,
Yeah.
because inside the OpenStack, if you're primarily running Kubernetes to serve your services, your application, so.
Yeah, sure. So the question is, what's actually the benefit of running Kubernetes below OpenStack? That's a good question, and actually during this presentation, we were a bit showing that Kubernetes might not be the best solution. Well, OpenStack is basically a collection of different applications. So Kubernetes is currently the de facto standard for running application in a standardized way. So I think the biggest benefit of Kubernetes is the standardization here. The question is if OpenStack, which is itself not written in a way to be cloud native, is really fitting into this picture. Does it answer the question?
I mean, it was more like what your benefit you're going to get out of running if your main workload is Kubernetes in your internal, your private data center. Does it make sense to avoid that extra layer and run Kubernetes on bare metal to begin with? Or I mean, I can see multi-tenancy is there, but what other benefits we are going to get out of that?
Well, I think our approach is that it doesn't really make sense. That's our approach. But as you can see, there are a lot of projects which choose Kubernetes. And what Kubernetes provides, you will have rolling upgrades. So Kubernetes has those deployment models embedded. You will have, you can revert some versions. Rollbacks, yeah. So there are some benefits related to how the services are managed.
Thank you.
Any other questions? So maybe I will have a question then. So who never installed OpenStack? Hands up. Okay, not many people. And who uses Kubernetes-based approach? Oh, no one? Okay. And maybe who uses Kolja? Oh, yeah. Cool. So thank you a lot, guys. And if you have any more questions, you have our addresses and you can talk with us.
Yeah, we hope that your deployments, hopefully your deployments doesn't end up with a HTTP status code like our room number.
So
Which is
we are surprised
404.
that the room was almost full because one of the doors is 404.
Thank
Thank
you.
you.